Millings, and in part 6 of this 6-part series on challenging mole conversion problems involving density and shapes, we are going to take another look at cylinders. So let's jump right in with an example problem. This example, it says an iron cylinder is made up of 5.50 times 10 to the 31st atoms. If its radius is 8.69 centimeters, then what is the height of the cylinder in centimeters? And last but not least, we need to round our answer to just 3 significant figures. So in this problem, what I like to do is draw myself a little picture so I can keep track of what's happening. But we have a cylinder here, and what we know about this cylinder is that it is made up of iron. And what we also know about this cylinder is that its radius here is equal to 8.69 centimeters. And one last thing that we know about this cylinder is that it is made up of 5.50 times 10 to the 31st atoms. And what we want to know is if we have a cylinder that is made up of iron, has this radius, and is made up of this many atoms, then what is the height of the cylinder going to be? So what we're asked to figure out here is we want to know this distance right here. We're asked to calculate the height of this cylinder. So we're trying to solve for the height. So let's think about this. How can we figure out the height of this cylinder if we know that it's made up of iron, we know its radius, and we know how many atoms it's comprised of? Well, the first thing that we're going to have to do is figure out the number of grams that this iron cylinder contains, or in other words, what is the mass of this iron cylinder? So what we're going to have to do is, in step 1, what we're going to have to do is we are going to have to use mole conversion to figure out the mass of this iron cylinder. Once we're done figuring out the mass, in step 2, what we're going to have to do is we are going to have to use our density formula and solve for the volume, or find the volume of the cylinder. And once we're done finding the volume of the cylinder, what we can do in step 3 and in our third and final step is we can use the formula of a cylinder and solve for the height. So let's see if this makes sense. What we're going to do first is we're going to convert the atoms of this iron cylinder here to grams. We're going to figure out the mass in grams. Once we're done figuring out the mass in grams, what we're then going to do is plug it into the density formula. We're going to look at a density table and figure out the density of iron, and we're going to solve for the volume. Once we're done finding the volume of this cylinder, we're going to plug that into the formula of a cylinder and solve for height. So let's go ahead with step number 1. In step number 1, it says that we have 5.50 times 10 to the 31st atoms of iron. And what we're going to do with the atoms of iron here is we are going to convert this to grams. So we want to cancel out atoms of iron, so we'll put that at the bottom of our equivalent statement here. And we're going to want to convert this to moles first. If we take a look, we can go from atoms to moles, and then from moles to atoms. So in our first step, we're going to convert the atoms of iron to moles of iron, and then in our second step, we're going to cancel out moles of iron, so we'll put that at the bottom of our little equivalent statement or fraction, and we're going to convert this to grams of iron, so we'll put that at the top. So now, what's the relationship that exists right here? What do we put in these empty spaces, in other words? Well, we know that 1 mole is equal to 6.02 times 10 to the 23rd, And we know if we take a look at the periodic table, like the one that just popped up on the screen in front of you, that 1 mole of iron is 55.85 grams of iron. And so now, if we take a close look, we can see that atoms of iron in the numerator and denominator cancel out. Moles of iron in the numerator and denominator cancel out. And so now all we have to do is start from the left with our given quantity, work our way from left to right, and if we come across a number other than 1 in the denominator, we're going to divide, and if we come across a number other than 1 in the numerator, we're going to multiply. So we'll take 5.50 times 10 to the 31st. We're going to divide this by 6.02 times 10 to the 23rd, and then we're going to multiply by 55.85. And we're going to end up with 5.10. We'll put the answer down here. .10 times 10 to the 9th grams. And this is going to be our mass. So we found the mass of our cylinder. It's 5.10 times 10 to the 9th grams. What we could now do in step 2 is we can now plug that mass into our density formula and solve for V. So we know that density equals mass divided by volume. But if we're trying to solve for volume here, we have to get rid of the fraction, so we'll multiply both sides by volume. Volume is now going to cancel. And what we're going to be left with is volume times density equaling mass. And what we can do here is divide both sides by density. Density will now cancel, and we're left with volume equaling mass divided by density. So what is the mass? The mass we just figured out. It's right here. It's 5.10 times 10 to the 9th grams. And what is the density of iron? Well, if we take a look at a density table like the one that just popped up in front of us, we can see that the density of iron is 7.874. 7.874 grams per cubic centimeter. This unit's going to cancel with this unit. And so we're going to end up with a volume of, let's go ahead and put this in our calculators, 5.10 times 10 to the 9th divided by 7.874, and we're going to end up with 6.48 times 10 to the 8th. We're running out of room, so I'll put that answer right here. So the volume here is going to equal 6.48 times 10 to the 8th centimeters cubed. So this is not our final answer, this is just the volume. This is our volume here. In our third and final step, what we have to do is we have to use the formula of a cylinder. If you remember from Algebra 1 or geometry, the formula of a cylinder is going to be this. The formula for the volume of a cylinder is volume equals pi times r squared times h. And if we're asked to solve for h, then what we need to do is we need to divide both sides by pi r squared. This will cancel. And so, to get the height of our cylinder, what we're going to do is we're going to take the volume and we're going to divide it by pi r squared. So what is the volume? The volume we just figured out, it's right here. It's 6.48 times 10 to the 8th cubic centimeters. And we're going to divide this by pi times the radius, which is 8.69 centimeters squared. And so when we put this in our calculator, when I take 6.48 times 10 to the 8th, and I divide this by pi, and then I divide this by 8.69 to the second power, we are going to end up with 2.73 times 10 to the 6th centimeters will be the unit that's left over. And this is going to be our final answer. So if we have a cylinder whose radius is this, whose composition is iron, and its and it has 5.50 times 10 to the 31st atoms of iron making it up, then the height of that cylinder is going to be 2.73 times 10 to the 6 centimeters, or 2.73 million centimeters. So this is a very tall cylinder. So if you like what you see, go ahead and click that bomb in the bottom right hand corner, and that will subscribe you to my channel. And feel free to leave any comments or questions in the comment section down below. And I really hope you guys found this helpful.